Alright, first of all, let's have a look at the solutions to the homework of topic 4b. Alright, since we are only talking about partial questions, so let's move to the question 1b. So here we're only want to calculate the determinant of these four numbers, right? So this question is pretty straightforward. So this determinant is -10 times 12 minus the product with these two numbers, right? Which is -5 times 6. And that's -120 plus 30, and that's -90, right? Alright, then question 2. Okay, first one. Okay, question 2 asks you to find the solution to each system using the Cramer's rule. Okay, so first of all, we need to calculate this determinant, which consists of the coefficient here. So 3, -1, 2, and 3, right? This determinant is 3 by 3 minus -1 times 2. So that's 3 by 3 minus -1 times 2. And this gives us 9 plus 2, which is 11, right? And we also need to find another determinant. Well, in order to find x, we need to replace the first column using the coefficient, using the constants 7 and 1. Then keep these two numbers unchanged. So that's -1 and 3. Again, this determinant is 3 by 7 is 21. Minus -1 by 1 is -1, right? So that will give us 22. And in order to have y, we need to find another determinant. This time we keep the first column unchanged, 3, 2, and replace the second column with the constants here. So that's -1 and 3. Then this determinant is 9 minus -2, which is the typo here. We should use 7, 1 here. So that's 3 by 1 is 3, then minus 2 by 7 is 14, right? So that'll give us -11. And therefore we know x equals, remember this number here is our determinant, right? Is a denominator, sorry. So we put 11 here, and for x, this is a numerator, 22. And x equals 2, and of course y equals, the denominator is the same, which is 11, and this is the numerator for y, for the second variable, right? And that means y equals -1. Therefore, the final solution is x equals 2, y equals -1, right? And of course, you could use another notation. You could also say the solution is this pair of solution, xy equals 2, -1. So you could use either one, okay? Any questions? Well, if no questions, let's have a look at the second one. Okay, remember to correct your solutions if you have not done them correctly, okay? And for the second question, the method should be the same. First, we need to find this determinant, 5, 3, 4, -6. That gives us -30 minus 12, which is -42, right? And next, we need to find this determinant, 1, 2, 4, -6. and this is -6 minus 8, which is -14, right? And last, find this determinant, 5, 3, 1, 2, which is 10 minus 3 equals 7. Therefore, we know x equals -14 over -42, which is 3, 1 over 3. And second variable y equals 7 over -42, which is -1 over 6. Therefore, our final solution is x equals 1/3 and y equals -1 over 6, right? Any questions? All right, good. If no questions, let's have a look at the next one. Okay, first of all, we need to simplify this equation, right? Apparently, this is not simplified. So first, simplify this equation will give us 1 over 3r minus 1/6s equals 1 over 2, right? And second equation can be simplified to -r plus s equals 2. And you could start from here, or if you don't like fractions, you can multiply 6 to both sides of the first equation. So I'll just start from here, okay? And again, we first need to calculate this determinant using the coefficients of the two variables. And this determinant is 1/3 minus 1/6, which is 1/6, right? Second determinant is replace the first column using the constants. In this case, that's 1 over 2 and 2. And that'll give us 1 over 2 plus 1/3, which is 5 over 6, right? And the third determinant we need to use is 1/3, -1, 1 over 2, and 2. And this gives us 2 over 3 plus 1 over 2, which is 7 over 6, right? And therefore, we know the first variable r equals, the denominator is 1 over 6, numerator is 5 over 6, so that'll give us 5. Second variable s equals, denominator is 1 over 6 as well, numerator is 7 over 6, so that'll give us 7. Therefore, our final solution is r equals 5 and s equals 7. Did you get it? Any questions? Okay, if no questions, let's have a look at the next one. Okay, this time we have a system of linear equations, ax plus by equals c, cx plus dy equals f. Okay, we know that Cramer's rule states that if the determinant abcd is a non-zero, then the solution of this system is given by a fraction of these two determinants, right? But what will happen if the determinant abcd equals 0? Okay, let's have a look at the special case here. So we know that ad minus bc times x from our previous lesson. We know ad minus bcx equals d minus bf, right? And we also know that ad minus bcy equals af minus ce, right? If ad minus bc is not 0, then we can divide both sides using that to find x and y. So how about if ad minus bc, in this case that's the determinant here, right? Because we know that determinant a b c d equals ad minus bc, right? If this equals 0, then the left side of both the two equations are 0, right? This means this is the left side of this equation is 0, the left side of this equation is 0. So whether this equation has solution depends on the right side, right? So first one, if DE minus BF equals AF minus CE equals 0, then we have infinite number of solutions, right? because no matter what x and y is, the left side is always equal to the right side. Both of them are just zeros, right? And in this case, one equation is actually just the constant multiple of the other. However, if in the second case, if AB minus BC, if either DE minus BF or AF minus CE is not zero, then in this case, the left side is zero, the right side, at least you have a non-zero number, right? Then either X or Y does not have any solution, because you can't have any number times 0 equals a non-zero number, right? So in this case, there are no solutions to this system. So we need to do a little casework here, right? Okay, have a look at the solution here, and let me know if you have any questions, okay? All right, if you don't have any questions, let's have a look at question number 4. So this time we have a system of 3 linear equations. Usually, if the number of equations is more than 2, we could use matrix method to simplify the process of solving them, right? Okay, first of all, we could write the matrix using the coefficients and the constants, because these questions are already simplified for you, and we know that. All right, so okay, first of all, let's separate the variables and constants first. So the first equation is equivalent to 5x minus 2y minus 7z equals negative 19, right? Second equation is equivalent to x minus y plus z equals negative 8. And third equation is 3x plus 4y plus z equals negative 1, right? Then the corresponding augmented matrix is 5, negative 2, negative 7, negative 19. Remember, we only care about their coefficients of the 3 variables and the constants. The second row corresponds to these numbers: 1, negative 1, 1, negative 8, right? And third row corresponds to 3, 4, 1, and negative 1, right? And remember that our target is to convert this matrix to a RREF form, which means for this 3 by 3 coefficient matrix, we want a matrix like this. Of course, there might be zeros like this, right? But if we have ones, the ones only occurs at the diagonal, and some numbers here, some numbers here, some numbers here. Then you can write the solution directly from that equation, right? Remember, the only operations you can do to the matrix are the elementary row transformations. So first of all, we could use the first row. Oh, sorry, we could move the second row to the first position because this number is lower, which is then we can use this number times -5 or -3 to cancel these two numbers, right? So first of all, we could move the second row to the first row, and this gives us 1, -1, 1, -8, and the first row becomes the second one, which is 5, and okay, let's move this row to the second position because 3 is smaller than 5, right? So second row is 3, 4, 1, -1, and the third row is 5, -2, -7, and -19. Then we could use first row times -3 added to the second row. The first row does not change. The second row becomes 0 here, right? Times -3 added to the next one. So here it will give us 7, right? And okay, let's just not changing the order of the first and second then. So let's just keep this row here. This is our second row, and third row is 3, 4, 1, -1. Okay, and first we could use a new first row times -5 added to the second row. This gives us 0 here, and -1 times -5 added to -2. This gives us 3, right? And this number becomes -12, and this number here becomes 21, right? You follow me? And then use the first row times -3 added to the third row, then this number becomes 0, right? And 4 becomes 7, and that 1 becomes -2, and -1 becomes 23, right? Then we could divide the second row using the number 3 to simplify that. So first row does not change. 1, -1, 1, -8. Second row becomes 0, 1, -4, and 7. Third row is 0, 7, -2, and 23, right? Then remember, we also want this number to be 0. So first row does not change. Then we could use the second row times -7 added to the third row. Second row does not change. And that's 0, 0. Then 26, right? And -26 here. And then simplify the third row divided by 26. So that'll give us 1, -1, 1, -8. Does not change. And 0, 0, 1, -1, right? Okay, remember we also want these numbers to be zeros, right? Always remember your target. This is your target. So next we could use the third row times a 4 added to the second row, right? So in this way, the third row does not change. 0, 0, 1, -1. And times the 4 added to the second row, this gives us 0, 1, 0, 3. Again, cancel this number here. Then we use the third row times -1 added to the first row. This gives us 1, -1, 0, and -7, right? Also, we want this number to be 0 here, then we can use the second row. Second row times -1 added to the first row. So the third row does not change. Second row does not change. And second row times -1, time 1 times 1 added to the first row. This gives us 1, 0, 0, -4, right? And it's already in RREF here. Can you see that? Therefore, you can directly read the solution from the last matrix. Each step is an equivalent transformation, so we know the final solution is this corresponds to the coefficient of the first variable. In this case, that's x, right? So that means x equals this number here, which is 4, -4. And that corresponds to the coefficient of the second variable, which is y. So y equals this number here, right? Y equals 3. And this coefficient is y is the coefficient of z, which means z equals this number here, right? Therefore, our final solution is just x equals -4, y equals 3, and z equals -1. Okay, have a look at the solution here. Let me know if you have any questions, okay? All right, if you don't have any questions, let's have a look at the next one. Actually, for the next one, the method should be the same. You can try this by yourself, okay? So here I'm gonna give you only the solutions. The final solution is x equals 1, y equals -3, and z equals 4. There, the solution is unique. All right, you can try to do the transformations by yourself. Okay, first of all, separate the variables with the constants. And the corresponding augmented matrix is 2, 1, 1, 7, then 4, 3, -3, 13, and 4, 2, 2, 14, right? And first of all, simplify the last row to 1, 1, 2, 1, 1, 7 by dividing it using a 2. And notice that the first row is also 2, 1, 1, 7, right? Therefore, you can use the first row times -1 added to the last row, third row. Third row becomes 0, 0, 0, 0, right? And of course, you can also use the first row times -2 added to the second row. Second row becomes 0, 1, -5, -1, right? So the last equation is actually useless because 0 times 0x 0y plus 0z is also 0. So that'll leave us an unlimited number of solutions. In this case, we could let y equals t, where t is any real number. Then we could solve x and y in terms of t, right? First of all, we know t minus 5z equals -1 from the second row, right? And this gives us z equals 1/5 t plus 1/5. And also from the first equation, we have 2x plus t plus 1/5 t plus 1/5 equals 7, right? And this gives us x equals -3/5 t plus 17/5. Therefore, our final solution is in terms of t, gives us x equals -3/5t plus 17/5, where y equals t and z equals 1/5 t plus 1/5, right? Where t could be any real number. So we use the number t to connect the set of x, y, and z. So this is our final solution.